section 3 is graphing linear equations in slope-intercept form. We are learning to find slopes and y-intercepts of graphs of linear equations. We are learning to graph linear equations written in slope-intercept form. So just take a minute and pause the video just to read the definitions of the two intercepts and what exactly slope-intercept form is. So the x-intercept is where does your line cross the x-axis? And that coordinate is always going to be some value, comma 0. So in this particular example, let's just guess this coordinate is 7, comma 0. The y will always equal 0 for the x-intercept. Whereas the y-intercept is where does your line cross the y-axis? And that coordinate is always going to be, let's say this one is 0, 6. In the y-intercept, x is 0. And that sounds a little confusing at first, but the more we practice, the more you will begin to understand. Slope-intercept form is going to become your new best friend. Slope-intercept form literally is the slope and the intercept. And a linear equation is written in this form, slope-intercept form. And the equation is y equals mx plus b. The slope of the line is m. Remember, we talked about how m stands for slope. And the y-intercept is the b. And then the x and the y in the equation are just any coordinate on that line. And again, we're going to go into more examples. So let's take a look at the first slide. Identifying slopes and y-intercepts. You're going to now look at an equation and tell me what is the slope, what is the y-intercept. So in example number 1, I'm just going to rewrite it. Y equals negative 4x minus 2. Slope-intercept form is y equals mx plus b. Memorize this. Write it down. Write it on everything. Doodle it. Tattoo it. I don't care. Y equals mx plus b is your new best friend. So if this is going to mimic this equation, well, we know my m, the slope, is the number right in front of the variable. So in this equation, my slope is negative 4. And b stands for the y-intercept, which is where your line crosses the y-axis. So my b, or if you would like to write y-intercept if b confuses you a little bit, in this case is negative 2. So this equation, when I graph it, has a slope of negative 4 and a y-intercept of negative 2. This example number 2 here is not on your note sheet, but I just wanted to show you sometimes they like to jumble things up. Is this equation written in y equals form? Right? Because remember, we're looking for y equals mx plus b. Well, it's not because I have this minus 5. So in order to get it to look like slope-intercept form, sometimes you got to do a little legwork to actually get it into the form you're looking for. Now it's in y equals mx plus b form. So what is my m? Here it is. Here's my slope. Again, it's a fraction. My m is rise over run, 3 halves. And my b, the y-intercept, becomes my plus 5, my positive 5. So let's try to actually graph. Slope-intercept form. Woo, look at that. How do I get this back? I'm sorry. Let's take this back up here. Okay, now I fixed it. Excellent. Okay, so slope-intercept form is y equals mx plus b. So looking at our equation, what is the slope? Negative 3. And what is the b? Plus 3, positive 3. So you always start at your y-intercept. This is how you're going to graph. So if this is your starting point, start here. Because I know where the y-intercept is. At positive 3, it touches the y-axis right there. That's your first solution to that equation. Then I take my slope, and remember, slope is rise over run. So if this whole number is not a fraction, let's make it a fraction. Now I'm going to rise, -3, run 1. Rise, -3, 1, 2, 3, run to the right, 1. Here's my next solution, 2, 1. Do it again. 1, 2, 3, run 1. Okay, we can't really go anymore because of the graph paper. So I'm going to take a ruler and connect the dots. That's it. That's how you graph a line in slope-intercept form. Okay, I'm going to do it again real quick to show you. You start at the y-intercept, which is +3. And then I rise over run. My rise is negative, so I'm going to go down. 3, run, +1 to the right. 1, 2, 3, +1. 1, 2, 3, +1. Connect. This is a negative line because my slope is negative, so it goes downhill. And my y-intercept is 3. The last example I'm going to do is the cost, y, in dollars, of taking a taxi, x miles, is y equals 2 5/10 x plus 2. Graph the equation and interpret the y-intercept and the slope. So we are figuring out how much is my taxi going to cost. This is what this equation is talking about. So I have y equals 2.5x plus 2. If we're mimicking y equals mx plus b, where is my starting point? My y-intercept is right here, the 2. So I'm going to start my graph at 2. Now I have to do my slope, which in this one is 2 5/10. Now we need it as a fraction because we're looking for my rise over run. So 2.5 or 2 5/10 is 2 1/2. If we make that an improper, it's 5 halves. That's my slope. So I'm going to rise 5, 1, 2, 3, 4, 5, run 2. Boom. So actually, let me erase this, okay? But I just wanted to show you. I rise 5, 1, 2, 3, 4, 5, run 2. Now I'm going to connect. Okay. How come this graph only had quadrant 1? Well, in real-world situations, you're not really going to go towards the negatives. And when we're going in a taxi, there's really nothing negative about that. So it says interpret. What does the y-intercept mean? Well, the y-intercept is my starting point. To get into this cab, the y-intercept started at $2. That is also called your initial fee. Right? Just to get in the cab, it's $2. Then the rate, remember, slope, a fancier way to say slope is rate of change. The rate at which you're traveling is 2.5 or 2 5/10, okay, or $2.50 per mile, right? X miles. So the rate that I'm going is I pay $2 to get in, and every mile is $2.50. That is the slope. $2.50 over 1. So $2 per 1 mile. Now try some on your own.